In the deep and unexplored expanse of the cosmos, between colliding stars and twirling galaxies, there are worlds that defy the imagination and push the boundaries of what is conceivable. Some of these worlds, although peaceful and alluring from a distance, are quite hostile and ruthless up close. While being shrouded in mystery, these are the planets that may genuinely be considered the scariest places in the universe. Celestial bodies always make such captivating topics, but these hellish worlds make the whole thing particularly fascinating. From raining glass to the burning ice, the conditions present on these planets are a testament to how this universe never ceases to amaze us. Some of these celestial bodies are rogue planets that don't even orbit a star, forever drifting through the dark abyss of the cosmos. However, unlike what is only seen in the realm of science fiction, these are actual planets discovered by remarkable astronomers and scientists who had the audacity to venture into the unknown and explore the illogical, unfathomable, and horrendous oddities of creation. Want to follow in their footsteps? Let's get the show on the road then. First on our list is HD 189733b, discovered back in 2005, orbiting a star in a binary system in the constellation Vulpecula. Since the main star in the binary is a variable star, due to the transit of the planet periodically eclipsing the star, it has been designated with the variable name V452 Vulpecula. The star system itself is located near the Dumbell Nebula, approximately 62 light-years from Earth. As the exoplanet transits the star, there's a noticeable decrease in luminosity of about 3%, creating the ideal conditions for the atmosphere of HD 189733b to be studied. This exoplanet is approximately the same mass and radius as Jupiter, but it orbits very close to its parent star, so it is known as a hot Jupiter, completing an orbit around its star in just a little over 2 Earth days. Due to the scattering of blue light by silicate particles in its atmosphere, the planet has a deep blue color, kind of like the color of Uranus. It has a scorching temperature well over 1,000 degrees Celsius, making it hotter than the surface of Venus. The nightmare world of HD 189733b is the killer you never see coming. To the human eye, this far-off planet looks bright blue, but any space traveler confusing it with the friendly skies of Earth would be badly mistaken. The weather on this world is deadly. Its winds blow up to 5,400 miles per hour at 7 times the speed of sound, whipping up all would-be travelers in a sickening spiral around the planet. And getting caught in the rain on this planet is more than an inconvenience. It's death by 1,000 cuts. This scorching alien world possibly rains glass sideways in its howling winds. This next hot Jupiter, WASP-12b, is located approximately 1,400 light-years from our home planet in the constellation Auriga. It goes around its host star incredibly close, and it takes only a little over 1 Earth day to complete. Try and imagine what it would be like to see the sky ablaze with a perpetual reddish glow. In addition, the planet is tidally locked, which means that one side of it is always facing the star, while the other is always hidden in darkness, with scorching heat on one side and freezing cold on the other. The gravitational effects are so incredible that they are tearing WASP-12b apart, slowly but surely. The planet follows such a close orbit around its star that its tidal forces are distorting it into an egg shape and pulling away its atmosphere at a rate of about 5 billion tons every second. WASP-12b has temperatures exceeding 2,200 degrees Celsius, which is more than enough to melt iron. It's high in carbon and other heavy elements, giving it a smoggy, poisonous soup of an atmosphere, which is unimaginably vast, with its huge plumes of gas pouring out into space as a result of the scorching heat. TRES-2b, located approximately 750 light-years from Earth, is a gas giant that orbits very close to its host star. It is classified also as a hot Jupiter, but what sets this sinister world apart is that it reflects less than 1% of the light it receives, making it darker than coal. Imagine standing on the surface of a planet where darkness engulfs everything around you. It's like being trapped in an eternal nightmarish twilight zone. So why is this planet so dark and gloomy? The answer can be found in the atmosphere, which is mainly composed of elements with light-absorbing properties, like vaporized sodium and potassium. These compounds literally devour almost all of the light that hits the planet, resulting in its astonishingly low reflectivity. Imagine standing on the surface of Tres 2b. The environment would be utterly surreal, with little to no sunlight. It would be cloaked in everlasting darkness, leading to a spooky and peculiar ambience. Despite its inhospitable conditions, scientists are fascinated by Tres 2b because it challenges our perception of planetary atmospheres. By studying this dark, spooky giant, we can obtain a tremendous amount of insight into the chemistry and physics of exoplanets, expanding our knowledge of the universe. But how did we even know Tres 2b was there if it's so dark and elusive? Well, there's this technique called the transit method. By observing the slight dip in brightness when the planet passes in front of its star, researchers can infer the planet's existence and characteristics. The discovery was confirmed by the Keck Observatory in Hawaii on September 8, 2006, by measuring the radial velocity of Tres 2b's parent star. In addition, the planet is tidally locked due to its close proximity to its host star. Therefore, one side is constantly facing the star, while the other remains in perpetual darkness. Tres 2b may seem like an eerie, light-devouring chasm, but it provides an excellent opportunity for us to study the extreme conditions that exist beyond our solar system. By unraveling the secrets of this dark world, astronomers can gain valuable insights into the diversity and complexities of exoplanets throughout the universe. Up next, Kepler 70b, also known as the Evaporating Planet, is a mysterious and exotic world beyond all expectations. Discovered over 2,000 light-years away in the constellation Cygnus, this rocky exoplanet is an absolute marvel, a marvel that moves along such a close orbit around its star that its surface temperature reaches a whopping 7,000 degrees Celsius, which is hotter than the surface of the sun. The planet is literally boiling away as a result of the extreme temperature. The intense heat is stripping away the planet's outer layers, leaving behind a rocky core. This unique occurrence has captivated astronomers and researchers, offering a glimpse into the life cycles of planets. But how did this planet end up in the state that it's in? The parent star holds the answer to that. Kepler 70, a dying star known as a white dwarf, is responsible for the fate of its companion planet. As Kepler 70 reached the end of its life, it went through the red giant stage some 18.4 million years ago, engulfing its planets. However, Kepler 70b managed to survive, albeit in a drastically altered state. The extreme conditions create powerful winds that blow away the evaporated material, leaving behind only the rocky remnants. It is said that Kepler 70b was once a gas giant like Jupiter, but gradually moved closer and closer to its star over time. This process, known as orbital migration, occurred due to gravitational interactions between the planet and its disk of gas, or planetesimals, changing the planet's orbit, causing it to migrate towards its star. Next, we're visiting a fascinating planet that challenges our understanding of what it means to be frozen and yet ablaze. Gliese 436b, aptly named the Burning Ice Planet, dances gracefully around its star in the constellation Leo. At first glance, it seems to defy logic, a planet covered in a layer of ice and yet exposed to searing temperatures, which soar to a staggering 439 degrees Celsius. Despite its icy appearance, Gliese 436b challenges the laws of physics and ignites our curiosity. What makes this frozen hell possible? Well, the answer lies in the planet's unique characteristics and its close proximity to its star. The atmosphere of Gliese 436b holds the key to this paradox. It consists of a delicate balance of hydrogen and helium, creating a thin shield that contains the planet's internal heat. The intense gravity from the red dwarf star adds to the complex interplay of the forces shaping this extraordinary world. Gliese 436b belongs to a class of planets known as hot Neptunes. Despite being much larger than Earth, its tight orbit around its star subjects it to intense radiation and gravitational forces. The planet's atmosphere contains a significant amount of hydrogen, which creates a greenhouse effect, trapping heat and maintaining the scorching temperatures. This unusual balance between heat and ice has astounded scientists. But how does the ice on Gliese 436b withstand such blistering heat? This wildly unique occurrence has to do with the immense pressure exerted on the planet's surface. The gravity on Gliese 436b is so intense that it compresses the ice layer, transforming it into a strange form known as hot ice. Under these extreme conditions, the ice behaves like a solid despite its high temperature. Next, KELT 9b. The heat of KELT 9b is too much for even molecules to remain intact. Molecules of hydrogen gas are likely ripped apart on the day side of this tightly locked exoplanet, unable to reform until their disjointed atoms flow around to the planet's night side. With a dayside temperature of more than 4,300 degrees Celsius, KELT 9b is a planet that is hotter than most stars. The star it orbits, called KELT 9, a blue A-type star that is likely unraveling the planet through evaporation. KELT 9b is a gas giant 2.8 times more massive than Jupiter, but only half as dense. Scientists would expect the planet to have a smaller radius, but the extreme radiation from its host star has caused the planet's atmosphere to puff up like a balloon. Another unusual thing about this planet is that it orbits perpendicular to the spin axis of the star. That would be analogous to the planet orbiting perpendicular to the plane of our solar system. 1 year on this planet is less than 2 days long. With each orbit, KELT 9b twice experiences the full range of stellar temperatures, producing what amounts to a peculiar seasonal sequence. The planet experiences summer when it swings over each hot pole, and winter when it passes over the star's cooler midsection. So KELT 9b experiences 2 summers and 2 winters every orbit, with each season lasting about 9 hours. The KELT 9 star is only 300 million years old, which is young in star time. It is more than twice as large and nearly twice as hot as our Sun. Given that the planet's atmosphere is constantly blasted with high levels of ultraviolet radiation, the planet may even be shedding a tail of evaporated planetary material, like a comet. The planet PSR B1257+12c, located approximately 2,315 light-years away, was discovered using the pulsar timing method, where the regular pulses of the pulsar are measured to determine if there is a planet. Life here, if it exists, would have to adapt to the harshest of environments. The unrelenting radiation from the pulsar showers the planet's surface, challenging the boundaries of what we know about life's tenacity. However, the most astounding aspect of this exoplanet lies in its peculiar orbital dance. It orbits its pulsar host star at an astonishingly close distance, completing the full orbit in a mere 25 days. The scorching heat from the pulsar bathes its surface in relentless radiation, making it an inhospitable and dangerous environment for any form of life as we know it. PSR B1257+12c offers us a glimpse into the extremes of the universe. By studying the effects of high-energy radiation on this planet, we hope to unlock the secrets of how life can adapt and survive in the most hostile environments. In Earth's atmosphere, a protective shield offers a nurturing environment for life to flourish. Its oxygen-rich composition supports a vast array of organisms, enabling complex ecosystems to thrive. This next planet is truly out of this world. 55 Cancri E, also known as the Diamond Planet, is a rocky super-Earth with a core made of solid diamond. Yes, you heard that right. A diamond the size of a planet. However, this unimaginable wealth comes at a chilling cost. The surface temperature reaches over 2100 degrees Celsius, making it an inferno where no living being could survive. From glass rain to eternal darkness and diamond cores, these worlds remind us just how diverse and terrifying our universe can be. Thanks for joining us today, and don't forget to subscribe to the channel for more mind-boggling space content. Until next time, stay curious and keep exploring.